So these notes are going to go through the 5 types of chemical reactions. We're going to start in this unit predicting reactions, but before we can predict, we just have to be able to identify the reactions. You need to pause the video and have out your pencil, somewhere to take notes, and your reference table. So go to your reference table to page 6. This top part called solubility rules, we're going to ignore right now, and we're just going to go to guidelines for predicting the products of selected types of chemical reactions. As you can see, there are 5 types, 1, 2, 3, 4, 5. I'm going to walk us through all 5 types in the PowerPoint. So this first type of reaction is synthesis. Synthesis is basically when things come together, and what you need to understand is that things on this arrow means that a reaction happened. So things on the left side of the arrow are what went into it. These are called my reactants. Things on the right side of the arrow are things that come out at the end of this reaction. So these are called my products. So in synthesis, this option A says formation of a binary compound. Binary means 2. So it formed a 2-part compound. So A plus B, so A reacted with B and it formed AB. Right? So that's one way you can see a synthesis reaction. Part B, though, says metal oxide. Right? So here M stands for metal. The O specifically stands for oxygen, and it reacts with water and it produces a base. Now, you have to remember from biology that a base is an element with OH at the end of it. All right, so if you see this, things coming together and making one substance, it is a synthesis. Part C is a nonmetal oxide. So here NM stands for nonmetal, O stands for oxygen. Reacting with water, there's my H2O, produces an acid. Remembering that from biology, acids start with H, and then they have an element at the end of them. So in general, synthesis is when 2 reactants join into one product. That means I start off with 2 things, and then at the end of the reaction, when they've mixed together and they've had a chemical reaction, they make one item, one compound at the end. If we look at this first example right here, Mg plus O2 produces, that's how I would talk about this arrow, produces MgO. If I try to match it with either A, B, or C, it looks more like A. Right? In the second example, I can see water here. So that means something had to react with water. Now, of your options, B and C reacted with water. What you'll notice is Li is a metal, so that means it's a metal oxide, not a nonmetal oxide. And it made this LiOH, which is a base, so this matches with type B. What's most important for you to know is that it's a synthesis reaction. If you're able to identify whether it's A, B, or C, that's even better. Decompositions, there are many types of decomposition reactions, but in general, decomposition means this right here. One reactant, so that means one thing in the beginning, reacts and it makes 2 or more products. So if we look at A right here, binary compounds, we've got AB, that's one thing. The arrow shows a reaction. What happens is that it broke apart into its separate elements, A plus B. All right, metallic carbonate just means that we've got a metal react with a carbonate, and at the end of the reaction, it produces a metal with an oxygen plus carbon dioxide. See, we've got metallic hydrogen carbonate. Here's the metallic M for metal. Hydrogen carbonate is this HCO3 part, and this is a specific way in which it reacts. Right, metallic hydroxide, here's my metal, here's my hydroxide, here's a specific way it reacts. Metallic chlorates, here's my metal, here's my chlorate, here's a specific way it reacts. This last one you can ignore, option F. What you need to know in general is that decomposition causes one substance, one compound to break apart. If you can identify whether it's A through E, that's even better. It'll help you tomorrow, right? So of option A, here if I try to name this would be potassium chlorate, which means it's a metallic chlorate. Option E, so this matches with type E. Next one is lithium carbonate. what you'll notice, it's one substance breaking into two. So it is a metallic carbonate, matches with type B. Again, it's just really important for you to know the decomposition. If you can't match it with the type A through E, that's something that we can work on. Single replacement. So single replacement means that there's one substance by itself. Like in this example, there's A, it's by itself. It reacts with a compound. So if you imagine this as BC being a couple, there's a couple right here, BC, and then there's a single person. Well, say they go to the prom, A kicks out B. All right, so A kicks out one of the people in the couple, and now AC are a couple. B is just all lonely and by itself. So that is called single replacement. This first type is a metal-metal, so that means that A has to be a metal and it replaces B, also a metal. In the B option, there's active metal. There's metal, replaces H from water. There's my water. And option C, active metal, here's my metal, replaces H from acid. Well, HX means that there's an H at the beginning. X can represent anything. So that is an example of an acid. Option D is halide. Halide, you've heard of the word halogen before. Well, halide's the same thing as halogen. So in this example, D kicks out C, so that after the reaction, the arrow, C is now by itself, and then B, D are paired together. This is very similar to A, but the way that they're different is that in A, they're going to be metals replacing each other, and in D, they're going to be halogens replacing each other. So in general, one element and one compound starts, and then you produce, at the end, you make a different element with a different compound. In this first example, we've got Li. You can see at the reaction that Mg is now by itself, so that means Li kicked out Mg. If I try to figure out if they're metal or non-metals, both of these are metals, so it is matching with type A. In the second one, you notice that Cl2 is now by itself, so that means F2 kicked out Cl2, or just Cl. F2 kicked out Cl, now Cl2 is by itself, and F and Cl are both halogens, so this is matching with a type D reaction. Next is double replacement. So for double replacement, imagine it as one couple going to the prom and there's another couple going to the prom. Well, they completely switch partners. So now A is partnered up with D at the end of the reaction, seen here, and then B and C pair up together, right? So there are two compounds on each side. The partners are switched, essentially. The difference between A and B is not very important for you to know right now. So long as you can see a reaction and see, well, here's a couple, and here's another couple, and they switch partners, so this is a double replacement reaction. It matches with type A. Combustion reactions are pretty easy. It's always following a very certain pattern. The hydrocarbon, what a hydrocarbon means is that there's a C. It's just a C. There's a C with an H. The numbers beside them can change, so I'm just going to put X and Y right here. All right. But it always is CH something reacting with oxygen, which is O2. Remember O2 because it's a diatomic. And it always makes carbon dioxide, CO2, and water, so H2O. All right, now this is always the case. If you see something that produces carbon dioxide and water, if there's a hydrocarbon, so a C something, H something in the beginning, then it's a combustion reaction, just like this example here. C2, H6, those numbers, 2 and 6 can change, reacts with oxygen to make carbon dioxide and water. So just by looking at the products and seeing this hydrocarbon can tell you that is a combustion reaction, right? Be very careful about this because a lot of students assume when they see this that it's a single replacement reaction because of the pattern, but specifically because it makes carbon dioxide and water, it has to be a combustion reaction. Combustion is when things explode, right? So in summary, to think about it, double replacement, partners switch. Single replacement, someone gets kicked out. Decomposition, it's like a couple that breaks up at the prom.